So if I want the theoretical yield of the titanium, that's asking how much titanium can I make? Theoretically, what's the maximum amount of titanium I can make? And that's going to depend on the limiting reactant. And I don't know which reactant is limiting. So what's given to me, though, is that I have 148 kilograms of the titanium chloride and 46.5 kilograms of magnesium. So is it fair to say that whichever of these two numbers is smaller should be limiting how much product I can make? Not necessarily, because knowing the grams doesn't tell me which one I have less of. And even if I did know which one I have less of, because I'm required to use them in a 1-to-2 ratio, just because I have less of one doesn't necessarily make it limiting. The limiting reactant is not really the reactant I start with less of, it's the reactant I run out of first, or I could say it's the reactant that allows me to produce less product. So the way we talked about determining the theoretical yield is to convert starting amounts into the amount of the product of interest. Because if one of my reactants can produce a certain amount of titanium and the other reactant allows me to produce more, I will only be able to produce the smaller quantity because I'll be limited by the reactant that shows I can't produce that much titanium. So I need to do that calculation. So I'm asking how many grams or kilograms of titanium could I make if I start with 148 kilograms of the titanium chloride. And also, if that's not limiting, I need a similar calculation to calculate how many grams of titanium I could make if all of the magnesium were reacting. So generally, I won't have a situation usually where all of both reactants will react. So these two calculations are saying, what if all of my reactants reacted? That will probably only be the case for one of my two reactants. Once I run out of that one, I won't be able to fully react the other reactant. So that's why whichever of these calculations gives me a smaller quantity of grams of product formed, that's going to actually be the maximum amount I can form. So to do this conversion, I got to cancel kilograms. So I want to go to grams. Initially, I realized that as soon as I want information about one substance, but I have information about a different substance, I need to get to moles. And if I have kilograms, the way to get to moles is to first go from kilograms to grams using the metric table conversion. Then, to get from grams to moles, I use the periodic table and the masses that are found there for the elements that are involved in these compounds. So right now I'm dealing with titanium chloride, TiCl4. So if I want to convert that from grams to moles, I need to get the mass of one titanium, which is 47.88, and add that to 4 masses of chlorine, or 4 times the 35.45, 27, and that gives me 189.69. So that'd be grams of titanium chloride per mole of titanium chloride. So the point of that, so I can cancel these things here. The point of that was to get to moles, because if I want to know how much titanium I can make from titanium chloride, and those are not the same substance, the only relationship I have between substances is the coefficients in front of them in the balanced reaction. So this particular case so happens that 1 mole of titanium chloride will produce 1 mole of titanium, because they both have a 1 as their coefficient. And then if I want to get theoretical yield in moles, I'm done. I just have to put that in my calculator. If I want theoretical yield in grams, then I just need to take, since this canceled, the moles of titanium I have and convert that to grams. I would just be using the molar mass, 47.88 grams of titanium for every 1 mole of titanium. And if you're setting these up and you're not including the substance you're dealing with here in these conversions, it's going to be difficult. It's going to be confusing. You're not going to know which grams cancel with which or which moles cancel with which. And that just makes it harder on yourself. So just put that information in there. Be complete about it. And you'll see things canceling much more readily. So that I see everything canceling here. And I've got units for a quantity of product that could be produced. So this doesn't necessarily mean I will produce this amount. This just tells me how much I could produce maximum, assuming all of this reactant were consumed, which may or may not be the case. So this is a tentative answer that I have as a possible theoretical yield, depending on how the next calculation works out. But once I plug this into my calculator, I should get 3.74 times 10 to the 4th grams. So I want to do the same calculation with the magnesium, because maybe I run out of it first and I can't produce that much titanium as I just calculated in the last example. If so, then I need to know how much can I really produce, and that would be dependent upon the amount of magnesium. So I want to start by going from kilograms to grams. Then I want to get to moles. So if I'm just starting with magnesium, I just need the molar mass of that, which is 24.305. Grams of magnesium per mole of magnesium. Once I've got moles, then I use the coefficients here. 2 magnesium for every 1 titanium. So 2 moles of magnesium for every 1 mole of titanium. A mole is just a number of things. So that's the coefficients in the balanced reaction tell me how many of those things. So I could say 2 atoms of magnesium to make 1 atom of titanium, or I could say 2 moles of atoms of magnesium to make 1 mole of titanium. So once I have the moles of titanium, then if I want to get to grams to compare to the other answer that we already calculated, I need the same conversion there. So when I plug that in, 46.5 times 10 to the 3rd divided by 24.305 divided by 2 times 47.88, and I get 4.58 times 10 to the 4th. So I've got enough magnesium to make this quantity of titanium, but I only have enough titanium chloride to make this quantity of titanium. So which is my limiting, or which is my theoretical yield? It's the top one, right? That's the most I can make, because once I make that quantity, I'm out of titanium chloride. That's what that calculation tells me. I've got excess magnesium. I've got enough magnesium to make more, but once I run out of titanium chloride, that's it. I can't make any more titanium by this reaction. So this is my theoretical maximum given the limiting amount of the titanium chloride that I put in. So that should be the answer to part A of question 1 on the practice exam. So then it says calculate the percent yield. So percent yield is always actual over theoretical times 100. So I want to know, this is the maximum amount I could have made. So if I actually made that amount, that'd be perfect. That'd be 100%. But I want to compare how much I actually get experimentally to the maximum amount possible given the limiting amounts of reactants I put in to figure out how successful the reaction was. So it tells me I made 24,347 45 grams of titanium actually collected, where I could have made this amount which limits me to 3 sig figs, and I got to multiply that by 100. So I do 24,345 divided by 3.74, which is 10 to the fourth, times 100, and I get 65.1. So I only made about 65%, as much as I could have. So that tells me the reaction wasn't that successful, and that probably need to look at ways to be more efficient at converting that titanium chloride into product. It was given, it says, calculate the percent yield if 24,345 grams of titanium was isolated. So that means if you actually did it experimentally and they actually collected that amount, that would be your actual yield. If the percent yield were greater than 100, that would suggest that it's not pure yet. Right? So this theoretical yield that we put in here assumes all of the titanium chloride is converted into titanium. But in most reactions, I'm also producing something else. So if I somehow measure a yield that's over 100%, meaning I've somehow measured, so it's obviously not the case here, but if I somehow measured more grams of titanium in the end than the maximum amount I could have possibly made, that's not possible. I can't get more than I could possibly make. What that means is that when I measure out my titanium in grams, I've probably measured some of the titanium I produced, but also maybe some of the side product is there that I haven't fully removed, or there's some solvent that I haven't removed. Right? So that means that I need further purification.